Next, I'm going to present our paper titled SenCAPTCHA, a mobile-first capture using orientation sensors. My name is Yunhe Feng, a PhD student in computer science. I co-authored this paper with Dr. Qing, Dr. Hairong, and Dr. Scott Ruoti from Department of Electrical Engineering and Computer Science, University of Tennessee, Knoxville. So CAPTCHAs are widely used to distinguish between bots and humans. There exist multi-type of CAPTCHAs, such as text-based, image-based, audio-based, and video-based CAPTCHAs. However, when deploying them on mobile devices, especially on small screens, we may suffer from some bad user experience, for example, the fat figure error. Besides, they usually require user to type in the text or touch the screen to solve puzzles. They don't explore other alternative user interactions that are feasible on modern mobile devices. Recently, Google proposed the no CAPTCHA, asking users to click the checkbox to verify they are humans. However, no CAPTCHA does not work in many scenarios. For example, when the cookies were deleted, when JavaScript is disabled, or when browsing the web privately. In these cases, a traditional CAPTCHA is still needed. So in this paper, we proposed the SenCAPTCHA, a mobile-first capture using orientation sensors. SenCAPTCHA mainly consists of two components, an animal background image and a red ball. The red ball is controlled by the built-in orientation sensors on mobile devices. So the users could tilt their phone or tablet to guide the ball to the key point of the animal to pass the SenCAPTCHA test. When designing SenCAPTCHA, we considered three principles. First, we would like SenCAPTCHA to be low effort. It means SenCAPTCHA offers an efficient user experience for most of users to solve it very easily without any additional expert knowledge. Second, inspired by sensor-based games, we adopt a game-like approach to make it more enjoyable. And finally, we designed a clean user interface for SenCAPTCHA to avoid any blurred visual elements. SenCAPTCHA works as follows. First, we initialize the ball's position, select and mutate an animal image. The image mutation here we conducted include rotation, zooming, and tiling. Then the user starts to tilt their phone to move the ball. We check the distance between the ball and the target key point in a real-time manner. If the ball is close enough to the target, we further analyze the ball's trajectory using dynamic time warping distance to distinguish between bots and humans. Otherwise, SenCAPTCHA read fresh sensor values to update the ball's position. In our paper, we utilized three machine learning approaches to show the image mutation we conducted can resist the detection of animal key points. To evaluate usability of SenCAPTCHA, we recruited 270 participants on Amazon mTurk. Each participant is required to complete 9 SenCAPTCHA puzzles on smartphone or tablet. We find the average system usability skill score is about 60, and the completion time is below 5 seconds. Also, difference between image mutations are not significant, indicating that the mutation will not increase the burden of solving SenCAPTCHAs. We also conducted another user study to compare SenCAPTCHA with other existing CAPTCHA systems, including audio-based, image-based, video-based, and text-based CAPTCHAs. We recruited 202 participants to solve these 5 types of CAPTCHAs on smartphone or tablet. For each of the CAPTCHA, participants complete 3 consecutive CAPTCHA instances. After completing all 3 instances, they provided feedback on their experience using the After Scenario Questionnaire score, or ASQ score. The ASQ score shows SenCAPTCHA achieves a better user experience than others. In addition, SenCAPTCHA has the lowest average completion time. Based on the user feedback, SenCAPTCHA was their favorite system for almost half of the participants. SenCAPTCHA and other types of captcha used in our study are open sourced at the SenCAPTCHA.org website. Thank you very much for your attention.